Namaste students. In our last lecture we have done some examples of chapter 13 for exercise 13.1. So in today's lecture we will be doing some questions from exercise 13.1. First of all, I have taken second question of the exercise. In this question they are saying that a vessel is given. It is in the form of a hollow hemisphere mounted on a hollow cylinder. So the vessel is hollow cylinder is there. On this cylinder, one hemisphere is being kept and both the vessels are hollow. Cylinder totally covering each other. They are saying diameter of the hemisphere is 14. That means diameter is 14. That means radius will be 7. In case of hemisphere, they are saying radius is 7. So if radius of hemisphere is 7, so in case of cylinder also it will be 7. Then total height of the vessel they have given to us, that is 13 centimeter. In case of hemisphere, this will also be radius 7 centimeter. So height of cylinder will be 6 centimeter. In total it has to be 13 centimeter. So in case of hemisphere, height is not there, it is radius only 7 centimeter and height of the cylinder is 6 centimeter. Now we have to find the inner area of the vessel. Inner area means only we have to, whatever we have to do, paint or color, we have to do it on inner surface only. So inner means inner CSA is to be calculated. So for calculating area of the vessel, we have to calculate inner area of vessel means CSA of cylinder plus CSA of hemisphere. So if we add both the curved surface areas, we will get our answer. Now CSA of cylinder means 2 pi RH. And in case of hemisphere, CSA means 2 pi R square. Now R is 7 and height of cylinder is 6 centimeter. So here we can take 2 pi and R as common and we are left with H and R. 2 pi is 22 by 7, R is 7, H is 6, R is 7. So we are having 7 got cancelled with 7, 44 into 13. So 572 centimeters square. This will be the area of the vessel which is being formed by placing a hemisphere on a cylinder. After question number 2, I have taken question number 7 of the exercise 13.1. In this question they have given us that the tent is in the shape of a cylinder surmounted by a conical top. Means what is given to us? Cylinder cylinder is being surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter, height of the cylindrical part, this height is 2.1 meter and diameter of the cylindrical part is 4 meter. Means radius will be 2 meter. and slant height of the top. Top means this conical top. Radius for cone also 2 meter and slant height is given to be 2.8. Now we have to find the area of the canvas required to make the tent. In case of tent, only curved surface area is being covered to make it. Canvas is required only to make curved surface area of the tent. So in case of cylinder also CSA and conical top also CSA. And remember, this canvas will not be used on the floor. Like this bottom part will not be made by the canvas. So only we have to calculate is CSA of the cylinder plus CSA of the cone. That will be the area of the canvas required to make the tent, complete tent. So let us start calculating the area. CSA of cylinder. CSA of cylinder we know 2 pi RH and CSA of cone is pi RL. We can take pi and R as common. We will be left with 2H and here we will be left with L. Now pi means 22 by 7. R is given to be 2. Height is 2.1 and stand height is 2.8 meter square. 2 into 2.1 will be 4.2. 4.2 and 2.8. After addition will give us 7.0. So we'll be having 20 by 7 into 2 into 7 meter square. 7 and 7 goes cancelled. So we have area of canvas as 44 meters square. In the question it was written that after finding the area of the canvas, also calculate the cost of the canvas at the rate of rupees 500 per meter square. So cost of canvas will be area into rupees 500. So we'll get our answer as rupees 22,000. So area of the canvas which is being formed by the combination of cylinder and cone is 44 meters square, and the cost of making this tent as a combination is rupees 22,000. After question number 7, I am doing question number 9. In this question they have given that a wooden article was made by scooping out a hemisphere from each end of a solid cylinder. Cylinder is given to you. From both the ends of the cylinder, hemispheres are being scooped out. Means that much surface is being cut out. If the height of the cylinder, the total height of this article will be 10 centimeter and radius is 3.5. They are telling us to find out total surface area of the vessels. Now don't get confused with total surface area. We don't have to use the formula of TSA. Here to see which areas is to be obtained. CSA of cylinder, then these areas. These are again CSA of hemispheres, up and down, both the places. Which area is to be calculated? This area, then this area, this. So what we have to calculate? We have to calculate CSA of cylinder, then the CSA of hemisphere and CSA of hemisphere. Means total surface area of article equal to CSA of cylinder plus double time the CSA of hemisphere. Means whatever we get for one hemisphere, we can double it. 2 into CSA of hemisphere. Now CSA of cylinder means 2 by RH plus 2 times CSA of hemisphere means 2 by R square so 2 pi RH plus 4 pi R square. 2 pi and R can be taken common. So here we will be left with H, here 2 and R. Now putting the values, 2 into 22 by 7. What is radius? Radius is 3.5 centimeter means 35 upon 10 into. What is H? H is 10 plus 2 into 3.5. Double of 3.5 is 7. So 2 into 20 by 7 into 35 upon 10 into 2 into 3.5 7. 7 and 10 17 centimeter square. Now go for cutting. 7 5s are 5 2s are 2 and 2. So what are we left with? We are left with 22 into 17. So 72s are 34, 34 and 3, 37. So after calculation we have seen that the total surface area of this article, which is a combination of cylinder and from both the ends hemispheres are being scooped out, that area comes out to be 374 centimeter